Okay, I think we'll get started. Good morning, everybody. Hi, my name is Amruth. I'm a senior researcher at the Indian Institute for Human Settlements in Sucharitha R. Also part of the Let's Talk Spatial coordination co-founder, whatever you like to call it as, with Aman, Tiaku, and Santosh. Both of them are not here with us today. They couldn't come, but I think you'll get a chance to interact with them also during our next meetup. But yes, I think we're all here at Skylark Drones or the IKP building here. And just a few notes before we start ahead, other than the welcoming part and all of that stuff. This is a completely open space, so open for discussions, but we'll also like to keep it respectful. So please do have a respectful conversation with your peers. You can obviously are free to share resources, links to each other's LinkedIn profiles, anything of that kind. That's the whole point of Let's Talk Spatial. Just a small history before we get started with our talks is that about 6-7 months ago, Aman and Tiakos, they sort of reached out to us saying that there is no spatial coordination group in Bangalore as of recent. Before we go to spatial, how many of you know spatial, like what geospatial is? I know there's a lot of drone folks here, so just to keep a common platform for all of us, any idea about spatial that you like to get clarification on? So spatial stuff, right? So geospatial is again like, this is the main point I want to say. So on our website, if you just open up, it just says spatial is basically correlating things to where they are on Earth, right? So we have lat-long coordinations with the coordinates that you put for, when you put a Google map and things like that. The X and Y latitude on a map is a coordinate. So any sort of business intelligence, any sort of research, any sort of practice that happens with relation to coordinates falls under the domain of geospatial, right? So geospatial networks, geospatial talks, all of that stuff. So that's the whole agenda for Let's Talk Spatial, is that we reach out to folks, we reach out to people who are interested in the geospatial domain. It could be anything, like we see today, drones has a very small impact for, or very small utilization of GIS, or very small utilization of coordinates, let's keep it simple, but its overlying impact in the GIS domain is massive, right? So that's the reason why drones and UAVs and everything in between is a huge trending topic in the geospatial domain. For a while, although I think it's still coming out in terms of accessibility for folks to get into drones, is still a ledger to cross. But yeah, that's Let's Talk Spatial. So if you ever go to the website, you can go and see where all we have had talks so far. So in the talks column, if I just take you, so we've had talks so far in a lot of different places. So the last one we had was at IHS at my institution in Sucharitha R. But previously our first one was at Spatial. Then we also had one at IIIT Bangalore and Microsoft Reactor Studios. So each of these places, what we do is we select a theme, and based on those themes, we try to find folks who are in that field, either accomplished folks in that field, or up and coming researchers in that field, somebody who's really into software engineering in that field, things like that. And we reach out to them to see if they're interested to speak about whatever topic they like to, something they're wholeheartedly into. And then they come, and then we do what we are doing here today. That's basically the whole idea about Let's Talk Spatial. Right, so again, this is an open invitation for you. If you are interested in to present anything, please do reach out to any of us. Or if you know colleagues or anybody who's also in this field, please let us know. Right. So yeah, I think that's Let's Talk Spatial. And before we go on, I'd like to give a small introduction to our first speaker. First speaker is Sucharitha R from Skylark Drones. She is the lead GIS consultant for smart work sites at Skylark Drones. Background in civil engineering, Sucharitha has conducted hydrology and flood risk assessment studies for over 50 clients, covering about 20,000 acres of land, with one of the shortest turnaround times in the industry. At Skylark Drones, Sucharitha has also worked on the applications such as volume estimation, shadow analysis, integrating drone data-based solutions into the existing standard practices of the construction industry, to name a few. So she'll be presenting on a topic for efficient enterprises with drones. So if you could give a small round of applause and welcome.
Thank you for having me over to the talk. I'm glad to be part of this. And to begin with, you have got a brief introduction about me. Thank you for that. And yeah, I have been working in this industry for like close to six and a half years now. I started off immediately after my undergrad. Got into Skylark as a GIS intern, and I've got an opportunity to work on various things, various sectors that we have evolved over. Right? So Skylark 2 it was very young when I started, some 2-year-old company. So we were also exploring. Back then we just started off as a drone manufacturer. So we were exploring where and all we could use the drones, what all applications we could try and solve. So with that, we have come through a great journey, I would say. Touched so many sectors, realized not many work out, found some sustainable ones, and trying to improve processes there. So to begin with, so today's topic, I'm talking about drones. We know that drones are largely coming in place in terms of replacing the surveying, the traditional or the conventional surveying that we do. So apart from the photography or cinematography use case, in the commercial, in the industry or this, other industries, it's primarily used for, surveying purposes. Try to make the reduce the manual labor that goes in and have a quick turnaround time. So that's what it's commonly known for. But as and when we started working with this drone data, we realized the potential the data has a lot more, right? It does not end at just capturing images and then photogrammetric processing, right? Once you do that, you figure out that you were able to generate with a little bit of GIS analytics and a little bit of software, right? Some good technology. You can actually provide end-to-end solutions for businesses. In the sense that you can start from the requirement, the basic requirement, to actually complete the entire analysis for the client, and this will happen within a very short time over when compared to the traditional methods that we have been employing, right? So that is where that drones have been coming up, picking up pace in different sectors. So to begin with, there are a lot of sectors in which drones can be used. Essentially, anywhere it's inaccessible to reach, or you want to have a quick survey, go get an aerial view of some data, right? Any industry, any area, this is where you have applications. So that way, there is no limitation as to where you can use a drone. But these are the few sectors where it's commonly being used, right? It's slowly picking up traction in terms of usage and applications. These are the set of different industries. Mining and construction taking up charge in India primarily because the government too is enforcing laws. So there again we are getting aid in terms of trying to go digital with respect to the work that happens. Some basic introduction. So today what I will be talking about is RGB images captured, regular photography done using drones, right? So of course they can have different payloads. They can have LIDARs, they can have other sensors, thermal sensors, IR, NIR, right? So I have primarily worked with the RGB imagery. So that is what I will be talking about and how it can be used. This is the most common one. So this can be achieved even with the smallest of drones that you see, right? All the weddings that you go, the common white DJI drone. With that as well, you can actually conduct the entire analysis with just that one drone. So they are that efficient and that powerful. And of course, with the Make in India concept, we have a lot of Indian companies who are coming up with their own versions of these drones, which are much more powerful, much more capable. So they're just slowly expanding the usage. So talking about the advantages, as mentioned, these three are the primary ones among the many other things. So scalability in terms of how quickly you are able to do, right? So whatever a traditional surveying method, say for example, if I have to take a construction site, typical surveying will take anywhere between 30 to 40 days when you're going manually with a total station or auto level. It goes up to 45 days with a lot of manual labor. You need many people with at least a couple of instruments and rovers walking around. Whereas this can be completed in one day. That a site of 200 acres can be completed within one day. the entire end-to-end data collection can be completed within one day, and the next day you have your photogrammetric processing run. Overnight, if you run it, you already have the data ready. So it's like as good as 2 days in which you finish your entire surveying activity. So that is where you can, so because it's increasing your productivity, you can scale it, to a larger extent. It's faster also. And another, I would say, the most favorite advantage of the drone data, over any other, this UAV data over any other traditional methods is, you have a lot of data points collected. Uniformly, you collect data points of every region within the area that you're surveying. Right? So you have pictures. We make sure the pictures are overlap so that there's nothing missed out. So it's like if a drone is flying in this direction, then we make sure we have at least 50 to 70% overlap so that the same areas are covered in more than 2 images, and we don't miss out on any features. So that way you have data points for every feature on the ground, and therefore you have, when you're processing that and you're trying to replicate the area, you've collected all the points, and your uniformity is there. The data with respect to accuracy or the measurement with respect to its resolution, it is there. So that way you do not have to rely on interpolating different points collected from total station and figuring out how accurate it is, or like in between the 2 points, that the area between the 2 points is not very accurate because you use some interpolation techniques and you can't compromise on the actual accuracy. So that is where the drones play a good advantage. So over the last few years, these are the different indices. These are some stats which is picked up, where the drones are being used is India again, primarily, and how they're working out. So drone has slowly picked up its use case. People are looking more towards digital surveying, and this is where they're largely used. Agriculture is now slowly getting a boost. Again with the help of the Indian government, we have spraying drones primarily, which spray fertilizers and all the necessary other requirements. But yeah, with respect to crop health monitoring and insurance, slowly they are also coming up. So today I'll be talking about 3 different aspects where the drone surveying plays a key role. One is safety, the other one is compliance, and the third one is productivity. So these are the 3 things that the drone surveying primarily offers, right? Or you can achieve hands down without any doubt. So the first one, if you say safety, right? So safety primarily because you do not have to enter the site. You can just stand in a remote location, and the drones these days are you have a transmission over 2 kilometers, transmission abilities of at least 2 kilometers, going up to 10 kilometers. So you just have to stay, on the road somewhere, the closest road nearby, and then you can, with the safety in a safe zone, you can fly in accessible areas. It could be mining areas, it could be, forest areas, or when you have government projects being constructed, there is a lot of land issues that happen. So if you send the people on site, we have personally experienced this. There have been localites who attack the surveyors because they think they're intruders, right? So all those safety concerns, one, are addressed with this because you don't have to really enter the site. And on top of it, after you get the data, there are other safety features that you can bring up using the data that you are analyzing. So for example, I'll take you to 2 use cases that has been of a really good significance with respect to the data collected. So first one is the haul road analysis. So a little bit about haul roads. Haul roads are basically roads within your mine. So the mine is a very active area, right? It keeps changing on a day-to-day basis. So you have unpaved roads which go into the pit and to the other area where they dump the collected mined material. So these are called haul roads. Because the roads there are one unpaved, like it's like just big, and it keeps changing. And the second thing is you have heavy machineries traveling on top of it, right? They are called dumping trucks. They are like very heavy machineries with tire heights of over 6 feet. So the overall machine height will be around a two-floor building or something. So when such heavy machine with a lot of load move around, your road naturally has a lot of undulation, right? And because of which their drivers are put at risk. because if they're first of all carrying heavy loads and it's narrow, it's just the width of the road is just enough to take the trucks. That's what is the requirement that they just met. They don't cater to any other requirements because they have to keep, it keeps changing. The scenario and the mines keep changing, right? So all-road analytics helps you assess the safety of these roads. Because there will be many cases when either the roads are very narrow or it's very steep. In instance of very steep, steep roads, you end up either with a heavy load, they can't travel ahead, or there are a lot of accidents reported worldwide. So that is where we figured out that we can actually use this safety use case of haul roads. Use drone data for the haul roads. Right. So first one is safety, but it has additional benefits. You have you're saving, because you're analyzing your roads. You know that they are not as per your design. These roads also they've been primarily designed for a ideal condition, which would help the trucks move with minimal fuel consumption and at a generic speed, optimal speed if you want. Right. So this is in addition to safety, this also helps figure out what is the slope of your road. So with just the drone data, the orthomosaic data that we get, right, which is the aerial imagery and the elevation data. So with just these two data sets, we are able to assess the slope of the road, see where they are violating the design standards, and then estimate by what the cut or fill should be to level out the road, right? So there are multiple options depending on each road, each mine, subject to mine. Either they extend the length of the road or they are doing cutting and filling activity to make sure that the slope is maintained. Right, so that is where this primary plays. This is in terms of site. Of course, the higher management will be able to monitor their production timelines, production costs, right? So these has features for different levels within the organization. That is with respect to roads. So similarly, hydrology. So we all know hydrology studies can be done with. You have a lot of GIS tools. We do a lot of watershed delineation. Right, do it for the large streams, figure out what are the areas that are, if you run the models, you have a lot of models available, open source models available, which will help you estimate the area of inundation which are prone to flooding. But then we largely do it commonly done using satellite data, right, because our watersheds or the areas are bigger. Usually they are streams or tributaries or for a dam or bigger purposes like that. But as and when we started working with different sectors, we realized that small sites also require this. It's done manually. We have water resource engineers who take the contour data and manually estimate what would be the water flow and all of that. Right? They go on site, they do a reconnaissance survey. So we can actually combine all of that and use a drone data. So you get a very highly accurate, high resolution data set for the site, and it's restricted to your site. And on top of it, you have uniform data, right? Contours, you have to interpolate the contours. You have to go to the Survey of India, get some whatever best available data set, and then try to make use of it. Whereas this, once you have, you can generate contours at 5 centimeter interval also, depending on how big your area is. It's because GIS is that powerful, we can do that, and that can be so you can run a basic hydrology study to estimate your discharge quantity, water system, where are the streams running in, and the best part is you can club it with the surrounding areas using the satellite data. What I figured out is, when I was working on this, I figured out we can actually take the streams from the drone data and burn it into the satellite data and then use that for the analysis. So that brings in that nitty-gritties or whatever that fineness that the drone data offers into the satellite data and enhances the data set. And you're able to predict floods, you're able to get the inundation maps. Once you get the inundation maps, when you overlay it on a drone image, ortho image, you can figure out what actual features are there. Sometimes it's just ponds, which require some filling, right? So things like that. You assess the in situ condition. And then based on this, you can come up with, so again, there's a lot of scope for mitigation measures. Stormwater drain design being the primary one right now, with so much work happening, especially in the solar sector. Everyone's moving towards more low impact designs, right? Like you have porous footpaths, right? So if you have a built up area, then you can do that, or you have retention ponds or bio ponds as they call. right? So people are moving. We've seen the progress from just taking stormwater drains towards moving towards these more sustainable measures. And these data sets. So if you get the data from the IIT, we get about 30 years of historical data for any place in India. So you're able to model and predict for the next 25-50 years we have flood. So that's actually useful, and constructions happen according to that. So the application, again, this is one application of GIS which is applicable, which can be used in multiple sectors. It's good in solar, it's good for construction when you're doing large tech parks or these multi-block apartments that are coming up. Right, so they find this. So primarily they were going with wherever you have a road going within your area, just build a drain next to it, water will flow, and that is how we are ending up with so much waterlogging issues in Bangalore. So likewise, so this will actually help them do that. When you are already doing your survey, you use the data to get a little more insights, right? So these are the two safety factors that we found. That has taken up a lot of scope. I've had the opportunity to work on multiple projects in both haul roads as well as hydrology. So in India, this is I would say gaining good scope. So next is compliance. So this is about how the government is trying to enforce digital surveying, trying to make with the Digital India movement. This comes in part of their trying to keep a track of the work that is happening. They want to, again, like I said, it has applications or usefulness for people at multiple levels within an organization. For the senior or the top management, you have monitoring, to see how the projects are being handled by the on-site people. For the project coordinators, it's keeping a track of progress versus when it started, a regular monthly maintenance activity that happens. So there are primarily two mandatory rules sent out by Indian government. One is for the mining sector, it's called MCDR, right? Then the second one is for the roads, highways, NHA. So the first one is, I would say, mining sector introduced by the Indian Bureau of Mines. So this was rolled out just last year. Okay, so they are any mines which have an area of more than 50 acres, right? Irrespective of what they are mining. They have to do a drone survey, submit the drone survey with their plan. So every mine has a plan, progress plan, a 5-year plan as to what they are going to do, where they are going to excavate and all. So this is where they want a drone survey to happen. They have mentioned, they've been very specific. I'm glad that they're taking such an initiative, where telling what is the resolution, what are the file formats that we have to submit in, so that everything is uniform and it's all being documented. And the government is setting up state-wise statutory bodies. Like for example, Orissa has ORSAC, which is right now monitoring the quality of the data. Right, so people can't just take some random drone data and give it off. They still have bringing in, they're doing it state-wise monitoring as well. So that is where this comes in. Again, two things. One, the government looks at it in terms of how these mines are, whether they're actually following their excavation plan, excavating where they've been permitted to excavate, right, and not illegally mining elsewhere or doing something else. Right. On top of it, they're doing other monitoring, such as they have to do afforestation. How many ever trees you cut off, that many or more has to be replanted, and then rehabilitation, because mining area happens. There are settlements, they have to rehabilitate. So all these monitoring is done by the government. Whereas the advantage for the mining companies that employ the services is they are able to keep a track of their plan. So the 5-year plan is again broken down to 1-year plan, and then they keep a track of how it's progressing, right? So they figure out that, they compare it to that, it's now done digitally. They have one platform where they can put up all their data. The AutoCAD drawing can be superimposed on the drone data. You can visualize, you have elevation data, you have visual data, right? And they can also check other things such as encroachments. You have slowly people encroaching on the sites from the settlement, right? And then they have much more applications such as all roads comes in, volumes comes in, right? So again, one data set, multiple advantages across different levels. Similarly, NHA, this is more recent than mining. So mining, so the MCDR happens every year between April and June. right? So to start your survey, start of the new financial year, within June 30th, they have to submit. They give 2 months for the mines to submit. So it's an annual activity. Similarly for NHAI, this is more of a video monitoring. So till now I was talking about photography. Take your RGB images, process it photogrammetrically, and then run all these analysis, run volume estimation, run basic digitization, all of that, right? Contour generation. But this is video monitoring. So this is right from the time the project starts, from the reconnaissance survey to till the date is completed. Every month they have to do a video survey of the entire stretch, right? And it's uploaded. They have a portal called Data Lake. The companies, whoever has won the tender and is constructing, they have to upload there. So this again is slowly taking traction. So right now it is just video just upload the plain videos. Moving forward, they are working on annotating the videos, right? You figure out where they are excavating. Again, you have leveling activities everywhere. So where they are doing the leveling activities, where your bridges come, afforestation. So all of these annotations on the video as well, whatever you're trying to do using the imagery is similar. A couple of those use cases are trying to be superimposed on the video so that you have one portal and one monitoring system for everything. So that is with NHAI. And finally, the productivity use case, or rather I would say, of the drones. This is where it all started off actually. Increasing productivity is where drones came into picture. That's how they became popular, because people started realizing that it's quicker, because it's quicker, it's more scalable, because it's easily scalable, you're doing more time, more of the same work. So this is I would say the starting stone for drone surveying, or any surveying activity. There are a lot of examples that come which, with respect to different use cases, with respect to different sectors, whatever sectors they are applicable in. So I have taken two again more popular sectors or use cases that are commonly being used. So these are some of the use cases which are being worked on by many drone companies pan India and globally, right? So volume estimation, right now if you are talking about, it can be in a mine. Where you compute, where they just go put stacks of material, different material, and they want to know what is the quantity of material there, right? Traditionally it's done, either they go take a total station, go on top of the pile and do it, or LIDAR, handheld LIDARs have come wherein you can actually do it much better. They are more accurate in fact, but then again it depends on the mounting device, what it is, right? So that is also one more application. So this is how the volume estimation is done. Again, because you have a uniform accuracy throughout the data sets, there's not much little interpolation happening within your data points. You are getting an actual ground truth. So with all our different experiences, we have been able to achieve 99.96% accuracy with different mines using simple photogrammetric outputs. Right, so this has been verified. So what they do is at the site they verify it with their own. They have a weigh bridge where they weigh the truck with the material, and then they also do the LIDAR surveys, right, for the stockyards where they have stored their material. So with respect to that, we've been done a couple of comparison POCs, and surprisingly we have been able to achieve consistently over 99% accuracies. So if you use the material grade, and you actually get the actual tonnage, which can be directly converted to your cost. Tonnage into whatever material rate, you get your cost, right? So again, upper management estimates work in terms of money, the lower management knows in terms of the quantity of work done that is happening. So it's a win-win for all. This is with mines, that is very common. Couple of years back we started doing this for construction also. So when you have these bigger sites, like I said, multi-block apartments which are being constructed, and especially if they're in the Deccan Plateau region where you have a lot of hard rock encountered, then there's a lot of blasting activities that happen. So they have to keep a track of how much blasting work has happened. So here the concept of vendor management comes in, right? Because they will hire another external vendor. They will do the blasting work. He will say this much amount of excavation we have done, you pay us for this much, and we will bill them for that much, right? So this will be employed by we are working for the construction company who employs the vendors, so that accuracy, there's a verification of how much work is actually being done and how much they are being billed for. So again, apart from progress, you also have these management related use cases that can be in. And inspection. So inspection, I would say, by inspection I mean inspection of it could be of different so say for example transmission power lines, pipelines, solar panels, right? Different entities which are either very dangerous or time consuming. So when in India, if you have say windmill or a transmission tower, you have people actually climbing up those towers without any safety harness, trying to figure out where the if there is a rust in one of the joints, or if your screws are not, one of the entities are not there, or if it's not aligned. So that is where the drone surveys come in, and first they bring in the safety factor for the manual labor involved, and then followed by the productivity, which will be, because the entire thing can be mapped within half an hour, whereas it's a 3-day activity per tower, right? That is what. So you can do videos, you can do 3D modeling, right? And you have, with a little bit of AI, you can actually just run your AI on the outputs and you get your different annotations, right? So you say this joint has this item is missing, or this is rusted, right? And if it's you can actually measure if they have any standards with respect to which they can compare, that can be done. Right, so that is with respect to towers or pipelines, for that matter, if there's any breakage or encroachment with plants, like you have vegetation growing over your pipelines or covering the pipelines, it's not good, if it's especially oil and gas, right? So there. And then when you move to thermal bands, you have solar inspections, finding the hotspots, right? Trying to see if all your panels are working fine, or if they're generating the same outputs that it was supposed to generate. Figuring out if there is any damage to any. So because we are able to fly low, we are able to get a high resolution data. A module will have, a panel will have very, very tiny cells, right? So you can identify it at a cell level. Say that this particular cell in this particular module of this table, that one particular cell in this table is, not functioning, and that is, you can flag it, and corrective activity can be done for that particular region. So these can be, and the best part is, these can be monthly, right, periodic. It can be different at whatever interval they desire. It need not be fixed. You can go fly whenever you want. Only thing is, you just need to have a clear weather. With the clear weather, it's like good to go. Right, you're able to achieve on an average 3 centimeter, but if you want, you can go as low as 1 centimeter resolution data sets as well. Right, so yeah, these 3 things I hope I've covered the major aspects of drone applications, wherein they're providing not just trying to substitute surveying with a more efficient method, but also providing a holistic solution for different sectors across different levels of management, having good use cases for everyone with just one data set. One survey, you have 3 outputs, 3 standard outputs, 1 ortho image, 2 elevation models, one with this, like all the features on ground DSM, right, and just a terrain model, DTM, what we call digital terrain model, with just 3 data sets. You can do like so many applications and so many things, provided what is the use case. So yeah, that is what Skylark has been working on as well.
Thank you so much. I think this is a very good introduction to drones. I personally don't have much idea about drones, other than that I want one. But I really would like to get into this someday eventually. It seems very, very, a lot of scope for a lot of things that we can do, especially for geospatial stuff. So we're throwing the floor open for questions. I have a few as well, and then if you're all into the mode of asking a little bit questions and getting things out during the time that we have now, we can take maybe like 3 questions totally, and then we'll go ahead later. So anything more, we'll have another networking session for a few 1 or 2 hours, as long as you're here. We have been informed that we can stay here till 4 o'clock, so I think let's see what happens. But yeah, Just a general question, more probably like about the process itself. But before we get started with drones itself, how has the law changed? I know that until recently, drones were a little bit of a problem, especially in a city like Bangalore, where like 40-50% of the land is defense land. So, what are the procedures for, let's say, an institution to get a drone license or a piloting license? Is it differentiated by your experience involved? What basically goes for that?
So yes, there has been a drone law that has been brought by the DGCA recently, right? So then they have worked. We have also worked with them in trying to categorize every part in India into different zones: green zone, yellow zone, and red zone based on the land over. So it has over the land use, based on the land use. So for example, if you have near defense area or airports, then they are red zones, right? So they are not flyable. There are yellow zones where you can fly with permission, green zones which do not require any permission. So Skylark itself had an opportunity to work with the DGCA. We came up with something called a digital sky, which is now rebranded as Watchtower. So it's an open source website, right? So it's just if you type in watchtower.skylarkdrones.com, right? Watch, I'll just show that. Watchtower Skylark runs, okay? So this is available for entire. So in India, this is the problem. We did not have this map before, right? A lot of other US, Europe had this map. So this is available for entire India. So wherein they've sourced different data sets and tried to get the fly zones, whatever permission areas. So if you can see different colors here. So if I click here, it says you are in a red zone. You can't fly, right? Why? And it's a special use zone. I think I've clicked somewhere near the HAL, which is close to this HAL airport. It comes under the HAL airport area, right? So if I move this, move out, say go to this yellow area. So this is near IL, right? So you have to count, take the permission from the DGC, and it gives you the details, right? You can upload if you have a KML of your area, right? And you want to figure out where it was, you can upload it here. This is open source. Anyone can access it. You can figure out where your area falls, and then you can use it for this thing. You get, and of course, apart from this, there are other things. So if you're doing any DGPS survey, you get your stats on GPS satellite visibility. Then because it's flying area, you get weather forecast, right? A couple of other features along with temperature, wind speed, which are important for flying a drone, right? So these can be picked up from here, and of course, and then you can even export it. Right? So you upload your this thing and then save it as your feature. You get a satellite view as well. So yeah, you can explore this website.
It's good. Okay, well, thank you. Nice. Any questions from the audience? Maybe take two questions.
Same question we solved it, but there is a clash of this. When we buy a drone, for example DJI, we have the maps of the same kind. Will that overlap with what it is, or is it the same open source of the same map?
So DJI, the thing is, since it's worked with Indian government, we have got the access to some of the restricted maps. Right? DJI being an external entity does not really have the accurate mapping of the zones.
But they do have kind of similar.
It will give you an overview, but it's not very accurate because, of course, to be honest, DJI, although headquartered in US, has a manufacturing plant in China, because of which is not very, Indian government does not favor it, right? So we wouldn't, you can use it, but it's not as reliable. Basically, this is also one from Mapbox. The open source layers is the same, with a little more information from the restricted data. Was also available.
I think the zones are updated because it's on your drone will not take off.
Yeah. Now your drones are this.
Oh, so the drones itself is linked to the geofence of the area itself.
So if you take a DJI drone, so they have something called map data updated. So the latest drones, if you are keeping it in red zone, it will not even take off.
Oh, okay. That seems actually useful. Then what about, you see the mini drones, the ones for videography?
FPVs.
What about them? Do they fall under the rules of BGC in India?
All of them have, they have different clauses, I believe, for this, and you have to and honestly, DJI drones is officially banned in India.
DJI drones.
You can't buy DJI drones. If you're buying, it's like basically black market.
Some of this market in India.
Yeah. So whatever has been bought before the rule came into place can be used. They have to be certified. They get a UIN number, unique identification number. The pilot has to get it done, whoever has it. If you have that, you can still use it, but you can't now. You can't buy DJI.
I do have a lot more questions, but I think we'll wait for Pavan also to speak and then have interaction with both of them together. But any last questions from the audience for all of us?
I have a question. In case of utility monitoring with the help of drones, so where the pipelines are underground, how will the drone monitor that?
Underground, not much, because you, if you depends on the sensor. If you have right, if you're going with your RGB, you can't get much. You just get the terrain, right? So if you're going for any other sensors, and then you will be able to pick it up. But apart from that, underground, you don't have much.
Anybody else have a question? I saw a hand raised. Yeah.
Can you explain on getting license for drones? So what kind of drones in India, what they use, which company drones they use?
You have
Procedure for getting license for that?
So you have multiple drone manufacturers, Indian manufacturers coming up with the Make in India, right? Depending on your use case, you have everything from commercial drones to defense drones being made, right? So I'm not very sure because we have moved on from this sector. So we have our pilot network, we just engage them. So I'm not really sure of the other manufacturers. But yes, there are piloting schools wherein you can train. It's a couple of weeks of training. You get your piloting license, and then you are good.
Drones are classified in different categories. You have EPC approved training centers. You have to approach them and get a training card. It's basically like the airline pilot.
Yeah.
Okay, thank you. Then this is very good. So before we go ahead with our next speaker, what we do usually at Let's Talk is that we go around the audience to introduce ourselves. And so basically, what do you do? Your name, what do you do, where you're from, anything about your work that you'd like to share with us, maybe how to hear about Let's Talk Spatial for more advertising for us also. But yeah, let's start with one end.
So I am Aman. So I currently work as data scientist at Blue Sky Analytics. So I am one of the co-organizer of this meetup.
Myself, Mayank Puri. I have been working as a product analyst for a company named Sixt. I have never worked anything related to drones, but I am interested and curious to be here.
Yeah, hi everyone, I'm Abhishek. I'm working as SSC2 at Rakuten, and I work with drone and UGVs. As part of my daily work, we mainly build drone solutions for Japan, which includes drone deliveries and solutions in medical areas.
Hello everyone, myself Anshula. I'm working as a geospatial analyst in Spatial Analytics, India Private Limited, and I'm working in an agricultural remote sensor. Thank you.
So my name is Archie Roy, and so we three of us are from the same company, and we are all geospatial analysts, and we essentially work with crop insurances and the banks are our clients. Yeah.
Hello everyone, myself Archita. This is my fourth time I'm coming to this meetup. So I'm from Spatial. We are currently working on different sectors like not only agriculture, also in utility monitoring and also crop insurance mainly. So I am very keen to know the drone sector and also we are very interested. So that's why we came here.
Hi everyone, myself Prithvi. I'm working as a project assistant in project called Mapping under KSR.
Hello everyone, this is Abhishek. I am an electrical engineer. Not related to any of this, but I am really interested, so first time I am doing this.
Hi everyone, my name is Sucharitha. I work as a project associate in the SSI Safe Nuclear Actions Program. And same this time I'm in this what I'm working on.
Hello everyone, I am Umar. Same department, same organization. I am a DL cadet.
Hello everyone, my name is Rahman. I am working as a remote sensing data scientist at Captain Fresh. So, I am exploring the potential of remotely sensed data in the agriculture.
Hi everyone, my name is Jyoti. I work as a project associate in WRI India. So we work towards providing remote sensing and GIS solutions towards environmental climate change, related to people's welfare. And since I am in Bangalore, I mostly work from home, from Agra, UP. And since I was in Bangalore this month and I had talked to Aman and a few other folks from the Let's Talk Spatial group, I thought that I'll just use this opportunity and see as many people as possible from the community. So it's really great to see everyone here.
Hi everyone, I'm Janvi. So I work at WRI as well with Jyoti, and we are working in the urban domain basically. And then apart from that, I myself personally am a sort of a drone enthusiast, just an enthusiast, and I actually went ahead and bought a drone. After procrastinating for like 7-8 months, I was like, yes, I am going to buy it. So I bought it, and I'm trying to figure out just not from any study point of view, but just as a curiosity, passion point of view. Yeah.
Myself Yogesh. I am from Karnataka State Remote Sensing Applications. I am pursuing my MTech and second year. I was interested about drones to get more information.
Yeah, hi guys, this is Sai Prakash. Working in subject analytics and working as a remote sensing engineer. We work on the domain of agriculture and cat modeling both.
Hi, I'm Asmita. So basically I'm also from subject analytics, working as remote sensing engineer. So my domain is basically agricultural part.
Hi, I'm Bharata. I work at Narbox, research product. I'm a geospatial data engineer. But this entire project was really interesting to learn different use cases for the geospatial data collection from drones. So yeah, I thought to draw and look for the different applications.
Hi everyone, my name is Sayyid Mutafi. Presently I am working as a GS project associate at Karnataka State Remote Sensing Application Center, where we georeference these maps and making it bifurcating into HISAR, which was previously at survey numbers. So now we are again, I am next moving into AVO, RO unmanned system, where they basically work on drones. So I had interested on it, so I came.
Hello everyone, myself Kashish. I'm working as RS and GIS consultant at KMS. So basically a carbon market consultant. And here I am, like as Amruth said, I also have the drones in my bucket list where I have to buy them. So this is the best place to be. So yeah, thank you. Thanks for organizing.
Hi everyone, myself Sundesh. I'm also from Karnataka State Remote Sensing Applications Center. I'm pursuing object science.
Short before I give you a long No, please no.
I am from a company called G6. We founded it 2 years ago. We are in geospatial and civil design and data capture.
So I'm Amruth. I'm a senior researcher at Indian Institute for Human Settlements. I mostly work with big data analytics, continental land cover mapping, population prediction, cloud computing. Whatever you can find that has a little bit of tech in it, I'm probably there. So yeah, yes, I think what we can do is also so secret announcement. People who come for 5 times to our LTS will get a free sticker. So I think you're on the list. 2, 3 of them. Newcomers will get from next time. So just let me know. We are trying to do merchandising next time. But yeah, I think we'll start with the next talk. We are right on time. I think you can set up your laptop.
feedback forms here. You can fill it up later on if you are interested. And you can put your questions also in there. And if you need PPT, yeah, you can drop your mails, I will share.
Yeah, we'll reach out to, I mean, you already shared with us, so I will share it out to the group if that's all. If there's any changes or something.
No, this is fine.
So yeah, our final speaker for the day, before we do something else after this, is Pavan Vyas. Is the Chief Technology Officer at G6 Solutions Private Limited, with a demonstrated history of working in road safety, road asset management and advanced surveying using DGPS, 3D laser scanners and drones. Pavan is a certified road safety engineer and auditor issued by the Indian Academy of Highway Engineers and also holds a PhD in asset management from VTU. Having varied experiences, okay, pursuing with the asterisk, sorry about that. Having varied experiences in conducting topographical surveys from 1500 plus villages in Karnataka for the Jal Jeevan mission using DGPS and UAVs to accident-prone or black spot locations using terrestrial LIDARs. A lot of experience. At G6 Solutions, Pavan tasked with implementing an incident management system for smart city applications. He will be presenting the applications of LIDAR in the AEC industry. So yes, the floor is yours.
Good morning all. I represent a company called G6 Solutions, where G stands for Geospatial and Engineering. Basically, our vision is to power geospatial technology, and our mission is to be one of the top leaders in geospatial. So these are the sectors we are working in. We brief about our service offering. We are in the geospatial, so we are basically we are very strong in surveying. So we have DGPS, LIDARs, and we also do mapping using GIS. And we also do data migration, whatever data we have on paper to the digital data. And we are also into consultancy. We do a lot of road surveys, road asset management. We've been currently doing the Jal Jeevan mission. We've done around 1,500 villages. And we are also into irrigation and water resources. That is a brief about a small brief of the company. So the topic for today is application of LIDAR in AEC industry. So what is a LIDAR? So LIDAR, it is a technology which is the full form is light detection ranging. It is very similar to radar, where radio waves for detection. Here we use light for detection and ranging. So it is a remote sensing method for examining the surface. So based on the reflection of the light, so we are able to determine the coordinates of the objects. So what is the principle? So there are actually two different methods of principles behind LIDAR. So one is time of flight, other one is spatial. So time of flight scan equipment. So they once a laser beam is fired from the equipment, so it goes hits the object and comes back. So the time difference is used to calculate the coordinate of the point. So this is generally used for long range scanners, say for mining, so 2 kilometer range scanner. So we use time of flight. So the other one is phase shift. So the phase of the wave changes once it hits the object. So that change in phase is used to calculate the coordinates. And that's the brief principle about LIDAR. So what is, people call it LIDAR. It is actually the technology, but it has to be called as 3D laser scanning. So 3D laser scanning is based on the principle of LIDAR, and it's a non-contact method. You don't have to go touch any surface. It can generate point clouds with XYZ coordinates. It has a day and night operation. Even you can do a LIDAR survey in pitch dark, and it acquires it's a direct terrain acquisition system. And the latest LIDARs can capture up to 2 million points per second. So there are different types of LIDARs. So the equipment can be mounted in many different ways. So the first one is the aircraft mounted. The same can be mounted on a UAV. So then we come to ground based, where it's a mobile which is mounted on a vehicle or a terrestrial LiDAR. This is a typical aircraft mounted LiDAR, where a small aircraft is used for. So this is the LiDAR sensor, where it is used for mapping of very large areas like a country. This is not very often used in India, but in countries like US, Europe, entire country is mapped with aerial data. So the data is available. Some data is available open source as well. These are the types of data that we get. So basically, they are collection of millions of points. So it is extensively used in power line detection, power line surveys. So the same LiDAR now recent technologies they have been mounting it on UAVs. So the same LiDAR can be mounted on a UAV, and they are using it for capturing information. And only problem, I mean, it's an upcoming technology in India. Not a lot of people are getting into LiDARs with drone. Again, you get a typical data that you get from an airborne sensor. So the second type is a mobile LiDAR, where this is the LiDAR unit which can be mounted on a moving vehicle. It can be also on a train, or if you are doing a rail circuit. So which is used to capture your highways. So it was actually a mandate to do all the highways which are going for construction. It had to be done using mobile LiDAR before the design. So the scanning is done. It can scan, till a speed of 100 km/h, and the data is captured up to say around 50 meters on either side of the road. These are some of the samples. I think if you can switch off. This one. Yeah, I think it's all. So these are some of the typical data sets that we have for mobile LiDAR. So these are done using a rail, where the LiDAR equipment is mounted on the rail, and they scan the entire railway line. Then coming to terrestrial LiDAR, which is something like a total station mounted on a tripod. So it can be a survey grade tripod or a normal photography tripod. So there are various equipments. So this is a 2 kilometer range LiDAR, so where you can capture if it is visible up to 2 kilometers. And this is around 6 kilometer range LiDAR, which uses a class 3B laser, and it is mostly used for in the glacier region where there is no much of human settlement. So generally we can use it for BIM, plant engineering, heritage, construction monitoring. It's a brief about where we can use. These are some of the typical data that we have captured using terrestrial LiDAR. So this is one of the film theaters. So it looks like a photograph, but if you I'll be showing the data in the end, so you can make out that it's collection of points. So how does a terrestrial LiDAR work? So I'll explain. So this is the equipment. So there is a laser source and there is a mirror. So once the equipment starts, the mirror rotates and the equipment will revolve 360 degrees. And that laser beam is used to calculate the coordinate of the point. So there is a vertical movement and there is a horizontal movement. So once you fix it at a place, so it revolves 360 degrees and 330 degrees. Only the place where the tripod is mounted, that portion is not captured. So this is time-lapse video of data scanning, where we where the equipment is kept at a place for around 6 minutes, then we move it to the next place. So and we capture that and then we take it and stitch all the data together. So where are LIDARs used? So architecture, BIM, it is very good documentation tool for forensics, where in other countries they are using it extensively. In India they have actually started a couple of forensics and the police department, they have a LIDAR. It is used for forestry, heritage preservation. Countries like Cambodia, they have the entire architecture as a digital twin. It is used in films like Bahubali and all those things. They've used it for creating the waterfall scene. So used in film. It is very much used for pipeline survey for plants, and we can use it for topography and shipbuilding, because to check the deviations, to compare the whatever is designed and whatever is constructed. And it is used for any 3D modeling we're giving VR to capture the exact measurements. So what are the data outputs? We can generate point cloud is the basic output. We can generate meshes. Then we can generate 3D models for simulation and visualization. And we can generate 2D floor plans. We can use it for volume calculation, accurate volume calculation. Use it for deformation analysis. And it's the best tool for as-built documentation. Broad applications, as we mentioned, we have worked in all these places. As-built, building, accident spot analysis, mine surveying, road transportation, reverse engineering, and plant engineering. The typical workflow, we basically what we follow is we plan. So we have the area, we plan. Then we go to field and we scan the plant or any structure. So these red dots are individual points, individual places where we have scanned. But then it is like stitching off your cloth. We stitch all the data together and create a point cloud data. So from so that process is called registration. Then we get the point cloud, and ultimately in any engineering we come to CAD. So we have to come to CAD. So whatever we generate in 3D, we can generate 3D drawings or 2D drawings. So ultimately the data is compatible with CAD. So we generate that's the end product of the whole life cycle. I think I'll show some of the case studies that what we have done for AAC. So this is for buildings. So nowadays the design. So earlier we were using STAAD and doing 2-dimensional design. So now we go for Revit, where we can do a 3-dimensional design. The entire building is designed as a 3D model. So this is a Revit model which was designed, and the same building was constructed. So and that whole building was scanned, and you can superimpose the two and find out what is the amount of deviation. So has the contractor done justice, or has he deviated from that? So to centimeter level, millimeter level accuracy, we can know that where exactly the deviation is happening. And for buildings also, so earlier if we had to do any measurements of the trusses, so we had to go up there and do the measurements. But here we can, so it was kept on the floor and we did the scanning and we were able to measure the trusses. So you can use it for reverse engineering. So this particular construction site, so the plans were not available. I mean, the plans were not shared. So what we did is we scanned and we generated the detailed measurable drawing. So this is the detailed measurable drawing which we generated from the point cloud data. For another building where the entire building was structurally documented and a structural drawing was prepared. We can go into such a detail where we can even identify the type of sections which is used. So there are standard sections, so we can identify which section, what is the exact specification of the section that is used. So this whole thing was, this was the same theater which was extracted from the LIDAR data. It's a very good tool for MEP. So you can see that majority of the corporate companies, so they have their MEP seed. So once the operation starts, the MEP seed. So where we come in is we before it is closed, so we can scan that and create a model, and we can use the same model on a AR headset, and the service engineers can pinpoint where the problem is. So they don't have to open up the entire room to check where the problem is. So they know exactly where that component is, and they can go back there and
What is MEP?
Mechanical, electrical, and plumbing. All your corporate company, your commercial buildings here.
Oh, these kind of things.
Yeah, here it is open, but they generally cover it with a false ceiling. So if there is a problem with some component there, but you don't know where it is, so you'll have to open the whole thing. But that will be avoided. We can generate a very detailed drawing for any building, any plant. So this is the LIDAR data, so we can go up to the machinery level. We can also do the machine level modeling. And we can combine that, and so if there is an upgrade that has to be, so that is proposed. So this part of the existing data, this is the proposed data. So we can see it in 3D. Next would be your verticality analysis. So perfect tool for that. So you don't have to, if you are doing a large construction, say 10th floor building, so there will be a certain amount of shift. So we can estimate here, our conventional method is we take one level at the bottom, one level in the middle, one level at the top. But here the entire surface we have levels, so we know exactly where there is a bulge or where there is a. I think many of you are from Bangalore, so you would have seen there is a stone or a monument which is opposite to the planetarium. So this is the same exact stone. So we actually did the volume calculation. This was actually, the stone was carved out, it was further to Bangalore airport. So they had to get this to Bangalore. So there is a conflict in between the government and the transporting agency based on the weight. So we did the calculation for the weight. So they had the density and we got the weight. Here we can generate sections at every 1 centimeter or 2 centimeter. Manually, if you do a manual measurement, it's hardly like 10 centimeter. It's also very difficult to take a section. So we can generate a watertight model where we can get the exact volume. This again for done for floor flatness, where this dimension was somewhere around 90 meters by 150 meters. So visually you cannot identify where there is a dip. So we can generate heat maps of where there is a high levels, low levels. We can generate that. This is very useful for a large. This was for a parking lot. The same thing can be done on wet concrete, as all of you know that for measuring a concrete surface, so it is conventionally you have to wait for the concrete to set. So that takes a day. And if you are going for a mass concreting, so the very last waiting so long and then see that there is some problem to correct, lot of cost is involved. So using LIDAR, we can scan and give the heat maps when the concrete is wet. So you don't have to wait. So if there is a problem, we can actually fix it when the concrete is wet, so that you don't have to spend a lot of money to correct it later. And again, same construction monitoring. So at different stages, we can do an exact plan and compare it with the drawing. It can be 2D as well as 3D during the construction. So we can find out how much percentage of work is done. So there's a company in US where they've been using LIDARs for estimating the. So they have LIDAR mounted on a robot. So it goes entire construction site and they do analysis on how much progress is. So no human is involved. So there is a monitoring progress from a robot. We can do non-contact measurement, so we don't have to. So this is the World Trade Center to Orion, where we can measure the top of the building without going to the top. With an accuracy of plus or minus. So the equipment accuracy is plus or minus 2 millimeters. So within few centimeters we can do the measurement. Again, a good tool for documenting structures which is inaccessible. So this is almost a 50-year-old dam where we did the as-built documentation. So the slope is very steep, so you cannot literally climb or do the measurement. So we were able to capture the entire dam, create a 3D model for that. To come to irrigation, you have captured the canals. So if you have a canal section, so we can superimpose and see how much quantity is required. Say how much damage has occurred from the original design. So then we can estimate the quantities in a very good manner to then it will finally come down to the cost. So we can create a good estimate of what is the quantity required. And for topography and same way at drone, we can do for large projects where we can give you accurate terrain data. So for tunneling, it's also very useful. So generally how we do is we have a design profile, and the construction is an independent process. So we can actually superimpose the profile on this and see where the section is correct and where the section needs to be corrected by filling concrete or other material. Again, it is used for asset documentation. So entire water treatment plant was documented using LIDAR. So you can see these are this side is the photograph, and these are the actual data. But when you see from behind, it actually looks like a photograph. And so we did a study for Karnataka PWD where we used LIDAR data, where we were able to even simulate the accidents, and we can see if there's a line of sight analysis can be done. So we did that with. So this was a joint project with College of Engineering. And we can do bridge monitoring, any structural monitoring. So even the cracks we can identify. So till now it's basically about civil engineering. So anything we can anyone has any questions.
You use for water. How do you use it after you take the LIDAR photo? You showed in previous slide. So there's a water body that you have already using LIDAR. What would be the use for?
This is for asset documentation. This is a treatment plant. So this is the photograph, but in LIDAR again, you cannot penetrate into water.
But in LIDAR you can.
You cannot. What you cannot? There is a different class of LIDAR.
So which LIDAR I mean?
That is no. So we are using a terrestrial LIDAR. So the one where you need water. So there is something called bathymetric grade LIDAR, which is not very commonly used. So they generally go for bathymetry. If you have to find out the depths, they go for bathymetry. And it's totally different.
I have a question. So like you were creating these 3D models, so using LiDAR, can you also tell if there are air gaps in somewhere inside object or a 3D object?
So yeah, no. So this is whatever laser we use are class 1 lasers, which are human shaped. So this is not penetrate.
Okay.
So it is only so if the LiDAR is here and standing here, so whatever is behind me is not
Okay.
visible. So it's I mean, if it was not human shaped, then we could not use the equipment.
Yeah. Okay.
So how long would it approximately take? Like for example, let's say you want to detect crack, something like this, like this size.
For a crack, it is.
I mean, no. What I mean is like, how long would it take like for the instrument to survey? Like as you said, it is like about 6 minutes to capture the environment. Let's say we captured this room as an environment and we want to detect cracks or something in the columns. Like how long does it take to process like from the instrument to, like say here is
This room typically, I mean, if you want a very large data set, we can do 4 or 5 scans, say around 6 minutes each scan, and around 2-3 hours of processing, we can generate the actual 3D data where we have to do a visual inspection. And if we have to go for ribbon or something, so that will take a little bit. Maybe around 5-6 hours we are able to capture and give the data.
Where do you process it? Like after collecting the data, after collecting from the LiDAR, how do you process it?
So, so the LiDAR has a data storage device. So we have a software. So every LiDAR manufacturer has their own software. So we use a LiDAR called Faro S350. So they provide a software called C. So we stitch in that. So there are also a lot of open source softwares like Cloud Compare where you can work on LiDAR data. It's basically like how you stitch drone data, you have to stitch it together, and we have to have a minimum overlap of 30% between each scan.
Now they are taken from mobile also, iPhone.
Yeah, I mean there are different grades of LiDAR. So whatever you have on iPhone is not a survey grade LiDAR. So there are applications. So we have also tried it out. So if you are doing this building, if you start from there and you come back, so there will be a lot of data shift. So you don't get the very accurate data.
Has to be stable.
No, even if you use a gimbal to capture, there is an error because that is not a survey grade LiDAR. Whatever is there in mobile. So it's a pretty much, a great technological advancement in terms of scanning is concerned. For a quick scan, we can actually use the phone for it.
Just to make our class. Just to make our class.
Oh, that's great.
No, we also, if in a site if we have to do some quick scanning, we can. So that will give us a fair idea of how the site is. Then we can take our LiDAR and we can do. Instead of doing a video, we do a scan.
Just like a recce of what we
Yeah,
do in the
something like a recce. We can just see some applications in marine engineering. So there is a new mandate in the shipping industry called, so they have to install a device called ballast water treatment. Basically, a ship takes in water to maintain the buoyancy. So if I'm traveling from one port to other port, so if I take water from Mumbai, I cannot leave it at Bangalore port. So that water has to be treated. So that technology has to be installed in the ship engine room. So it is a very complicated test. So you don't have any conventional method to capture the data. So we can capture it using a LiDAR. So this is one of the ships that we have captured. So you can see that, it looks like a photograph, but all are individual points. So you can take it to any 3D modeling software and you can design it. And so one of our projects, so we did the scanning in Vizag. The ship was heading to China, so the design was done in US, by the time it reached China, so the components were ready and the components were installed into the ship. So the docking time was only limited to a day or two. So you can see that the world is you can reduce lot of time. Otherwise, for months together, the ship has to be done. So that documentation has to be done. These are a couple of scans of the ships. It is very good for plant engineering. So these are cement plants which were constructed somewhere around 50 years ago. So they don't have any drawings. Now they have to go for modernization. So for that we use the LIDAR to create the 3D drawing. From where the designers use it for designing the new infrastructure to make sure that there is no collision with the existing one. Because there are a lot of pipes, so none of the drawings are updated. So majority of the drawings are not there, and even if it is there, it is not updated. So we create entire 3D documentation for the plants. That was the cement plant. So the chocolate making plant, where the entire plant is documented. And say you have a factory in Bangalore, and it's in the heart of the city, and you want to move it to some other place. We can scan and give you the replicate drawings to replicate it elsewhere. If you want to move it, or if you want to even replicate the same plant, so we can scan and give to millimeter level accuracy. And it's not just limiting to plant, so we can also do mechanical components where for retrofitting. So this is a turbine where some component had to be retrofitted. So we use it to scan and we create the 3D model. You can do physical measurements, condition measurement, but the time taken for doing that will be huge. Again, for chemical plants, cement plants, any plants, for retrofitting we can give a 3-dimensional drawing. So this is again for a automobile plant. So we have actually done entire assembly line for the plant. So they have something called a digital twin. So if there is an upgrade that they have to do, so first they do it in the digital and then they go for implementation. So for that we create the preliminary data of the existing plants. Again for piping, so the main advantage of this data is you can now there are so many advanced tools where if you are designing and you can just run a clash detection algorithm where you know there is a clash with the existing structure already. So you can bypass that and take it in a different route. So that is the advantage of having the 3-dimensional data. Also done for heritage documentation. So we have actually documented Vidhan Sarda from the exterior for generating a rivet model. So the entire Vidhan Sarda was documented. Even the small minute components were captured. So this is the rivet model that we have generated out of it.
How do you capture color?
It's like the tripod. So you have to go entire. So here, so basically we went on 4 sides, and then we scanned from the top, and we stitched everything together. So this almost, because we were allowed only to work on the weekends, so it took almost 4 weekends to complete that.
For the top view, you went into some building.
Yeah, so this is from the software.
Okay.
So you can rotate it in any direction.
But you took it at the
yeah, it is always on the ground. On the ground and on the roof. So capture the entire data. Someone.
No, I had raised, but there was the same thing which I was
So it is all, I mean, so you have the capturing mechanism is your VI. So we have a terrestrial LiDAR, so it is always on the tripod. So in the software you can go into any view. And for capturing any statue, so we can capture that, and this is the mesh that we have generated. So you can take that mesh and do a miniature model of that. You can 3D print it as well. So this is the Tipu Summer Palace in Bangalore. So this is an image, and we can generate the plans like this. So we can generate a 2D plan. So you can see the position of the columns, the wall. We can generate it directly from the software. So these are the physical data where it can be used for modeling. Basically, if I want to replicate the same thing somewhere else, so I have the detailed data. Next one is we did document a temple in Kosavadalu. So this was a project with RV College of Architecture, and they are extensively involved in documentation. So we documented the entire temple. So we were able to capture even the small idols where the details are captured. And this is some of the carvings. So that is the left side is the LiDAR data, and right side is the digitized drawing from it. So you can create a pretty accurate drawing. So most of the architecture students, they do manual drawing, so we can replace that with digital. And this is the column, so we can get the profile. So we can have the very accurate contours. And this is just the 3D, 2D drawing, so we can also create it in 3D, so how it is. So it can be, if we do the model correctly, we can 3D print it. So if you scan, the whole temple can be printed as a miniature model. So coming to the advantages, it's basically a non-contact, so we don't have to go touch any surface. You have massive data, which is impossible to collect using any conventional method. And you have a fast turnaround, so this reduces your field operation, but increases to a certain extent of your office work. And you are exposed to less hazard. So if you are doing in a traffic environment where you have to scan, so you are not restricting the traffic for a long time. Say in plant, so you don't know what is running in the pipe. So it can be a very hot substance or cold substance. You don't know. So you don't have to physically go touch the tank, the pipes. And it has a day or night operation. So the scanner, how it gets color is, so there is a image sensor which takes photographs, which takes a 360 degree photograph. So from that, the point clouds are given a color information. So it's basically a point cloud, it's only X, Y, Z. From the photograph, we add the RGB to that. See, if RGB is not required, even if this is a pitch dark room, we can do this. It actually works in the dark. It works well in the dark. And it's a site on your desktop. So you have your entire site on your desktop. You don't have to go back. So even if you miss a small thing, if you are doing it conventionally, you have to go back to the site to capture that, the minute detail. So this avoids, it's like your site is on your desktop. So more accurate, less manpower on the field, but more manpower is required on the processing side. But now a lot of advanced tools are there where, say, if I have to disguise this pipe, so earlier it was like manually I had to draw it. Now, if I just pick one point, it will draw a pipe automatically. The softwares are getting advanced now. So I can show this window and it will draw a window. there is no scope for manipulation. That's the best part of it. That's why it can be used as evidence in court. So even if you manipulate 1 or 2 points, nothing will happen. There will be millions of points, and it will reduce your site visits. If say your site is in some North India somewhere, every time you go from here to there and come back, number of site visits and your cost increases. So because site on your desktop, so it reduces your and it gives you a more visual presentation. And this LIDAR data can directly be taken into a VR. You can take it to a VR environment.
I have a question regarding the working principle of how LIDAR actually works. Is it different from our camera senses the RGB of it, and then because you are moving around the sensor, you are able to detect the, as you said, coordinates. So it's working on those principles only to model it out, and there's still opaque points. Do you extrapolate those? Does LIDAR does that, or how it works?
So LIDAR has a laser source.
Okay.
So it's not just the camera.
Okay.
Camera is just to give the color information. So the laser is something like your total station or your measuring devices or your electronic measuring devices. So in your conventional total station, you keep someone holds a prism and that point is recorded. But here, that person holding the prism is replaced with the object. So it hits the object. So the laser beam from the device comes, hits the object, and it goes back. So that is used to calculate the point. So there is no RGB is not used to generate the point. This is the direct terrain information.
But there can be certain opacity if there is certain complex, you can say, structure that is there. There can be certain opacity where the light is not getting reflected back, which you are saying.
That happens. So there are certain materials which will reflect a lot and will create a lot of noise. So it is depending to the LIDAR engineer who is going to the site has to define. So there are certain parking lots where we cannot scan. So the floor are highly reflective. So you don't get a very good data. So that kind of places we'll have to take a call.
And in Rivet model where you are doing like in an open environment, is it more difficult to build it, or there is a different technology to do that riveting of a building or something?
No, Rivet can be. You can do any structure. So there is no limitation as such. So it depends on your data. So you have a data of your structure outside, you can do that. You can do a topology. You can generate contours in Rivet. It's a very good tool for documentation.
If I want to buy it, how much would it cost?
Starting survey grade LIDAR will be somewhere around 30 to 40 lakhs.
30 40 lakhs.
Yeah, that is for the hard work.
Okay, that's something that we can't have on the public list, but there are more accessible. But thank you so much, Pavan. That is a round of applause, please. I feel like I regret taking computer science as my engineering. If I knew there was so much testing in civil, I probably might have gone there.
It is actually not true.
It's a mix of here and there. Okay.
And we have to, even being a civil engineer, I have to learn a lot of software.
Yeah, that's good. I do have a few questions though, but before anything that was in conversation that we might have interrupted, anybody had to ask? Yeah.
Another question. So, this does not underground also? Like seeing the soil or something?
No, so this, whatever LIDAR is class 1 laser, so it cannot penetrate. So you cannot go inside. For that, we have to go for a ground penetrating radar.
Because there were some images like when there's the saying on the walls, right? When the drying is there, like how it's drying in the dust.
Yeah, so that was, the tunnel. So where we can go, we can capture.
Okay, that's not penetrating.
Say if you have your tunnel, water tunnel or something, where we can see where a person can walk, we can capture that. It's basically like our eyes, whatever we see, it can capture.
I do have one question that's mostly in the. So how is the processing like? I know it's all point clouds, and point clouds are much more denser than regular Excel calculation software. So So what would be like sort of the recommended configurations of software or hardware, something that would be generally used, I guess.
For the hardware part, in the systems, you require a typical high-end workstation for sure. Otherwise, you cannot open this data set. For software, there are a lot of open source which is coming up now, something like Cloud Compare, which is a very quite fast software. Otherwise, so there are mostly closed source softwares like this point cloud data can be taken into Revit. Any of the Autodesk platforms, it supports it. So you can use that. And QGIS is supporting LIDAR data. Three of our companies are doing a lot of work for integrating LIDAR where we can work on.
So just to add to that, so how do you now decide where do I place the LiDAR machines? Is it more like some of the images which look like photographs, like I said, I couldn't tell from back. Like I said, it doesn't penetrate. So what about the back sides of things that you can't capture? So you have to.
It's basically where to go, and it is kind of based on experience that where we decide. But a simple rule, like if I'm standing here, whatever is visible, capture. So whatever is behind you, it will not capture. So it's basically like a human eye where whatever you see, it captures.
So for rooftops, I think a lot of confusion are there, and we saw the Vidhansala.
Yeah.
So even so you have the terrestrial radar put up on the roof of the building.
Yeah. So how we did was the entire Vidhansala, all four sides we manually kept the places, and we took the stairs and we went on top. Where from the top, so we did scanning in the top and on the edges, where a part of data was available from the ground. So there is some common data. So we were able to stitch the data together.
So then you do part by part as you move around the roof.
It is basically like, say if I have to scan this room, I keep one here, I keep one in the center, I keep one there. So I mean it's, we just have to keep in mind that we should have an overlap. So from here to there. So I cannot just do one scan here and go outside and do one. I cannot stitch that. So I'll do one here, I'll do one at the door, and do one outside. So it's basically like visualization. And a thumb rule, like different scanners have different ranges. So based on the experience and some of the recommendations, we can go and check.
That's all the questions I have to this.
Like what resource do you recommend to get started with LiDAR?
Resource in it.
Resource in the sense if someone wants to learn LiDAR technology.
Again, there are.
Like just a starting point.
Starting point is yeah, there are a lot of companies who are using LiDAR data. I mean, who have LiDAR. So and a lot of private. So actually, LiDAR is not a very new technology in India. We have been doing a lot of data processing. So we have large companies who are doing data processing of all the abroad projects. All the projects drone LiDAR flying, the data is processed in India. So the entire US or UK. So even for a small project, they have a LiDAR. So there are a lot of companies who work on LiDAR. I mean, getting it. I mean, people are not so familiar. For using it here, but yeah, I mean things have changed. We got our, I got introduced to LiDAR in 2020. So that time I was in my second year of engineering. So we had a company there, other company. I was doing expenses there. So I learned LiDAR in 2012. So once I graduated, then I am a highway engineer, but I've shifted my. I've actually worked little on highways than more on the surveying part.
Yeah, you are. So one, I just wanted to know, you said the point cloud. So they just have the X, Y, and Z. Right?
Is it okay? I will show the one sample data.
Yes. I just wanted to know how do you classify them? Like if this is window and this is wall and this is switchboard. Can we do that?
Yeah, we can do that. So there are softwares for classification. So it is a semi-automatic process. It is not 100% automated.
So the data points just carry XYZ, they don't have anything else.
XYZ and RGB.
I mean, they have the RGB, so they use that to classify.
Yeah. And you can also without RGB also, because there is geometry involved.
Yeah.
This is the entire temple that we have captured.
Which software is this one?
So this is software called Scene. So there are so this is a proprietary software the scanner manufacturing company.
Oh, scanners.
So every scanner manufacturer has their own software. So
What is the configuration of the camera?
this Xeon processor, 4 GB dedicated graphics and 7 GB of RAM.
Even then it takes time. Oh.
Still loading. How would you quantify resolution pointer? Is it the same as RGB images or is it
No. So we basically we have something called resolution is the point spacing. We in our scanners we have so from the scanner at 10 meters. So what will be the spacing up to 2 points. So that is the unit of measurement. So if you want, we generally do it around 6 mm. You can go up to 2 mm point spacing. So if you are doing a 2 mm scan, each scan will take you 2 hours. So you cannot do entire area. So we do a quick scan, and if you have to do a particular area of which higher density is, we can do that and we get data. Sorry. This is just the image. This is a this is the RGB image, but the point cloud is behind this data. So you can also do any quick measurements that I have to do. Can actually I can do the measurements. Can show me the measurements. So this I'm doing and truly I can. I can see it in 3D. And do the measurement in 3D. So these are scans with color, but you can also do without. These are black and white scans where no color is taken because these scans are quicker and
What are those green dots?
so those are something called targets. We use a sphere kind of thing to, which can be identified by the software. Basically, it will make the process easy for stitching the data. So we can do because we have a lot of geometry, so we can use the geometry to do the thing, but this will be more accurate. So these are the noise points where people keep moving. So that we can clean it out. So if I have to just sorry, I'm actually loading the data from my hard drive. And we can take this data to any 3D modeling software. Any Autodesk software we can.
Is there any handheld device that can be used just for
iPhone?
There are.
Then iPhone.
So whatever I talked, so there is a different technology called SLAM technology. So it also has a LIDAR, but it's a handled LIDAR. So where you can capture data, but the accuracies are, it's not as comparable to a record. You can achieve that.
So what they use it for? What kind of use case?
Do a quick scan. Depends on the purpose.
Like that gaming thing you would see, no? Augmented reality game.
So if they want a very core scan, so they can do that, and very specific, they can go to the terrestrial LiDAR.
Cool. Any other questions? This can be either for both of our speakers, or we do have some time, so we did send out an email saying that is anybody interested out here to present something on your own, some lightning 10-minute talk. We would be more than happy to lunch. Something that you're working on, something that you'd like to share. Come up and speak for like 5-10 minutes. Anybody? I don't want to pick up people like our class teachers. I'm not really glad. Maybe next time. Thank you. I think this has been great. Thank you all for coming. I'd like to thank Sucharitha, whole Skylark team here for hosting us, and then all of you also to come out on a Saturday morning. Hopefully there wasn't too much traffic, but there will be traffic if you leave now. So let's sit, have some chai, coffee, network for like an hour or something, and then we can. But, yeah, that's all for the. Thank you.